All right, so this is the lesson on 1.4 in our textbook, which technically so it's all about angles and how do we measure angles, how do we classify them. So before we actually jump into any particular definitions, what I just wanted to go over is quickly how do we actually measure angles and how that compares to measuring of segments. Right, so on the left I have some dot paper. So if I wanted to draw a segment and I wanted to measure how long it is, what I would basically be counting is how many spaces, right? Did it take me to travel from one endpoint to the other? So I go 1, 2, 3, 4, 5, right? So this particular segment would be considered to be 5 units long if I agree that between every two dots, horizontal and vertically, would be 1 unit. It's a little different with angles. So with angles, you have two rays that make up an angle. So you take one ray, and to measure an angle, you have to kind of measure how far do you have to sort of rotate in order to get to the other ray that would be the other side of your angle. So something like this would be how we measure an angle. Right, so I'm going to use a highlighter and I'm going to highlight my actual angles just to kind of show you. So I traveled from the red ray to, I'm going to change this ray to a different color so it's a little easier for us. So let me just change that to, let's make it blue. So, you know, the measure of the angle is basically how many degrees did it take me to go from red ray to the blue ray. So in this example, I'm using a grid, and if you count the number of sort of wedges you have around, you're going to count 36 wedges, which means that every single wedge is but it's actually 10 degrees, right? So to go from here to here, it took me 10 degrees, another 10 degrees, another 10 degrees, and another 10 degrees. So if somebody asked me for a measurement of this angle, I would have to say that it's 40 degrees because it took me 40 degrees to travel from one ray to the other. All right, so let's take a look at some formal definitions and a few examples. Okay, so we're going to start by just agreeing on how we are going to name an angle. Right, so again, as per our previous discussion, when we actually make an angle, it consists essentially of two rays, and the angle itself is the angle, the angle is between the two rays, right? So an angle consists of two different rays with the same end point, right? And you know, of course, I didn't really draw an example where it wasn't, but here, for example, this is your same endpoint. So what they're saying is, you know, let's pretend you had a ray and then another ray where they don't actually have a common midpoint, right? Then you actually wouldn't even have an angle, just two random rays. So that's why it is important to have a common or the same endpoint. All right, so the rays themselves are going to be called the sides of the angle, right? So we're talking about this side and then this side. So you have two sides. And the endpoint has a very special name, and it's going to be called the vertex. So this would be considered this point, the endpoint, so it's a point, would be considered our vertex B. Right, so how can we name an angle? So first I'm going to name our angle that we have in this picture. So when you name an angle, we usually use three letters, and it basically would kind of guide somebody as to how this angle would meet. So for example, for this angle, I'm going to start with C first. So I would have to say angle CBA. So angle CBA. So this is the little, I guess, angle symbol is the geometric symbol for an angle. That's how somebody knows you're talking about an angle, not a plane, for example, right? Because we also use three letters for a plane. Now, instead of that, I can also travel in the other direction, for example. So I don't have to start with letter C, but I can name my angle something different. So for example, I could say angle, and I can go ABC. Notice that my vertex is consistently in the middle. So this is your vertex. And then the last way I can name it, and you can't always do that, but sometimes you can name an angle just using the vertex. And the reason why I'm allowed to do this here is because I only have one single angle, right? So if I say angle B, no one's going to wonder, like, what angle B are you even talking about? So they're going to know that this is the only one. And you're going to see the difference in the picture of sort of when we cannot do that. So there's 3 different ways you can name this angle. Notice that the angle symbol is always in front of it. All right, so name 3 angles. So I'm going to try to color code it, right? So the first angle is going to be, so let's take a look. So you're kind of taking pairs of rays and look at that angle, right? So that angle, so I can say, again, X is a vertex for 3 different angles. So I can't really call any of my angles angle X because no one's going to know what I'm talking about. So I have to use 3 letters. So I can go in the WXY direction, right? So WXY. Or I can also name the same exact angle and just reverse the order, YXW. Again, notice that my vertex, my letter X, is in the middle both times. Well, that's not the only angle we have, right? We also have this angle right here. And then for that angle, let me see if you can see we'll try that. No, it's not the best. I'll use black. So for this one, right, I can go angle YXZ. So I can go YXZ, or I can go in the reverse direction. And this is kind of similar to naming segments, right? I'm allowed to go from one endpoint to the other without really caring about the order. And then the last one, the last angle that we have, so I'm going to erase all my highlighting so it's clear what is the third angle. So the third angle is sort of this large angle. I'm going to use the TL, right? So this the entire angle. So sort of the angle between this ray and then this ray. So then what I would do is I would call it angle. So first I'm going to go this way. So WXZ. So WXZ. Or I can also go in reverse and I can call it ZXW. So these are all the different angles that I have on my diagram. Now for classifying angles, again, I'm making this video before our lesson. After the quiz, you're actually going to work on this in breakout rooms to see if you can remember, hopefully, what each angle is. So I'm going to go somewhat quickly. So before we do anything else, I'm going to recall our 4 types of angles. So we can have an acute angle. We can have a right angle. We can have an obtuse angle. Or we can have a straight angle. So the acute angle basically has to be anything that is more than 0, right? Because you need some space between the rays essentially. So it has to be more than 0 degrees, but it also has to be less than 90, because as soon as you hit 90, right, you are making a right angle. So, and again, you need to be more than 0 because you need some space between your angles, right? So for example, you really can do a bunch of things. Again, remember each wedge was 10 degrees. So like this can be an example. It's not the only angle. I'm going to highlight in between just so it's clear which angle we're talking about. So this one, for example, would be a 40-degree angle because it took me 4 wedges from one ray to the other. In order for me to be a right angle, we are going to go 9. So I have to be very careful. I have to go and count 9 exact wedges. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Because I have to make sure it's exactly 90. And what we can actually do is have this very useful symbol. It's like a little square box, and that would tell somebody that we just made a right angle. Now we can also have an obtuse angle, and it has to be more than 90, right? Because again, if it's 90, that's it's going to be right angle, and I totally skipped the word then, so I'm going to throw that in. So more than 90. But it also has to be less than 180, because as soon as it hits 180, you are now dealing with a straight angle, and it's going to kind of look like a straight line. So for an obtuse angle, again, if we want to be more than 90, but not quite 180, 180 is going to look like this. It's basically going to be exactly 18 wedges. So it's going to just kind of be two opposite rays, actually, to kind of help us with some of the vocabulary. But let's get back to the obtuse angle, right? So I have this obtuse angle. I'm just going to carefully count how many wedges it took me, so I know the exact number. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So this would be a 150-degree angle. And this little grid's going to help you to measure them without having to bust out your protractor, which you might have, but you might not have at home. So, all right, and our last angle was the straight angle, and it was exactly 180 degrees. And there's 360 degrees in like a full circle. So basically, this is exactly half. And that would be your straight angle. All right, so that's pretty much it for, well, almost it for definitions. There's one more thing that is going to be important for us. So sometimes when you read a description, and sometimes you are going to have to draw a diagram, right? So sometimes you're going to read and they're going to say this point is in the interior of an angle, right? So what does it mean to be in the interior? So let's do this one, right? So this one's going to be in the interior. And then this is going to be not. Okay. So I'm going to say point E. I'm going to draw a picture. So point E is in the interior. So like, what does that mean, right? So let's draw an angle. Doesn't matter which angle we're going to draw. And to be in the interior, you essentially have to be between the points that lie on the on each side of the angle. So, think about, you have this one ray, which is one side, this other ray, right? Think about all of the points in between. Right, so it's kind of like if you look at this point on this ray and this point, and you connect them, like these are all the points would be on the interior. But again, if you just use my highlighter, so it has to be just a point in the highlighted area. So for example, this would be considered point E, and it would be considered in the interior. Now, to be not in the interior, all you have to do is basically put your point somewhere outside of your angle. Right, so if I have my angle, again, I'm going to use my highlighter to kind of highlight all of the space between them. So this is my interior of the angle. So if you're reading a description and they're saying that point, let's do F, right? So point F is not in the interior, so it could be somewhere over here. So sort of outside of the two rays. So point F is not in the interior. So that's what it means to be in the interior or not. So, and it really has to do more with just reading a description. All right, so angle addition postulate. So all it says, it's really not that bad, right? So it says that if P is an interior of angle RST. So we're going to start by drawing angle R. S, remember S has to be your vertex. And we'll do T. And point P is going to be somewhere in the interior. So I'm going to put point P right here. Okay. And they're saying the measure of angle RST, which is the big black angle, is equal to the sum of the measures of the two angles. What they're basically saying is that if you want to know how many degrees it took you to travel from this ray to this ray, right? Because that's going to be the measure of that angle. What you would need to do is you'd have to figure out how many degrees it took you from point R to P, right? So sort of again, but think about like angles. It's 1, 2, 3, 4, 5. It took me 50 degrees here. And then it's going to take you another 1, 2, 3, 4, 5, 6, 7, so 70 degrees here. So if somebody asks me, what's the measure of angle RST? all I would need to do is add up the 50 and then 70, because that would give me the total amount of degrees I would need to travel or rotate to go from ray SR all the way to ray ST. So that's all it says. So it's the measures of angle RST, no, RSP, right? That's my yellow angle, and angle PST. And I'm going to help us with the color coding. So this is our yellow, oh my goodness, okay. This is our yellow angle, and then this is our green angle. All right, so let's take a look at some quick questions. So find the measures of angle QST. So QST, right? So all we're going to do is we're going to look at the total number of degrees it would take me. So how many degrees did it take me to go from here to here? Well, all I would have to do is the measure of angle QST. Notice I have this little letter M that shows up if I'm talking about the degree measure. And I have to add the 42 degrees and the 47 degrees. And then together, let's see, what do they give us? They're going to give us 89 degrees. So that is the measure of, oh, I'm going to do 52 degrees. It's too early. So 52 degrees, which would make it 99 degrees. So there you go. So it's the measure of that angle. Now in example B, right, they said find the measure of angle NPM. So before I do anything else, I'm going to grab my highlighter. So NPM, they're talking about this. So what I'm noticing is that I'm noticing the straight angle that they showed me, right, because they have a straight line. So this ray PM is opposite of ray PL. So this is 180 degrees. So if I have to figure out the measure of angle NPM, I need to find the difference between the 180 degrees and the 79 degrees that I don't want to include in my angle. So that's going to take me and give me a measure of 101 degrees. All right. So what I'm going to do is I'm going to suggest you pause the video, and I'm going to embed a question here where you get to throw in your answer for question 1 and question 2, and then I will continue the video and you'll get to see whether you were on the right track or not. So what I'm going to do is I'm going to write down the answer. And then hopefully this is the same answer that you saw. So the measure of angle ADC would be the total of, so remember, this is going to be the measure of the angle. So how many degrees did you have to sort of rotate? So 21 degrees and 44, so the total is 65 degrees. So hopefully you answered 65 degrees in your question. In number 2, they ask you to find the measure of angle WXZ. And they don't. It was WXZ. I know it's going to be like WXY is just 90, but WXZ, right? So what is going to be helpful, or hopefully was helpful, is this 90-degree box. And basically that means that the two angles together were 90, right? So to go from here to here, it took me 90 degrees. So if they just want to know how many degrees were from here to here, so you're going to take your, so measure of angle WXZ is going to be the difference between 90 degrees and the 26 degrees that we didn't travel, right? Because you kind of stopped short. So the whole thing would have been 90. You traveled and you still had 26 degrees left over. So think about sort of what is the difference. So 90 minus 26 should have been hopefully 64 degrees for you. All right, halfway done. Another example, so we're going to step it up a notch a little bit, and we're going to throw in some variables in here. So they told us a measure of angle LKN. So LKN, which means that this is the measure they're giving me. How many degrees did it take me to rotate? 145 degrees, right? And they asked me to find the measure of this angle and this angle, right? So LKM and MKN. Well, the good news, once I find my two little angles, the sum should be 145, and I'm totally going to be able to check if things made sense for me, right? Well, I have to start with an equation. So the first thing we're going to do is we're going to set up an equation, right? So the sum of the two angles has to be equal to 145 degrees. And I'm going to help us out with the highlighting. So here is our yellow angle, and here is our green angle. Right, and then the total is 145. So if we just carefully do the algebra 1 part, so we're going to combine like terms. So 2x plus 4x is 6x. 10 minus 3 is positive 7. So 6x is going to be 138, which means that x is 23. Now, they didn't ask me for x, right? They said, what's the measure of angle LKM? And what is the measure of angle MKN? So what you're going to do is you have to go in and kind of substitute in the x value into here. So it's 2 times the x value. So it's 2 times the 23 plus 10. And that's going to give you 56 degrees. And then you're going to go to our green angle, right? So we're going to throw in x being 23. So 4 times 23 minus 3. And that's going to give you, let's see, what does that give us? That is going to give us 4 times 23 minus 3, 89 degrees. And I feel like something's wrong. Let's see, 4 times 23 minus 3, okay. And then the other one, 56 plus 89, nope, nothing's wrong. So the way that I was checking is I was adding the two numbers together. For some reason, I wasn't thinking it was for 145, but I checked with my calculator, it is. Right, so the sum of these two angles for me should be 145. So if I do add 56 and 89, this looks great. So I know that I did everything correctly. All right, so again, I'm going to pause the video. I'm going to have you work out these two examples on your own. And you're going to throw in your answers, and then as the video continues, you will be able to check your answers to see if you did it correctly and if you're on the right track. All right, so for number 3, all right, so hopefully you solved this out and you said these two equal to 180. So I'll help you with an equation, or just I'll set that up just to make sure that if for some reason you didn't get the right answer, you could see where you went wrong. So you'd add them up and you said it has to be 180 degrees, again, because this is, it's a straight angle. The x value should have came out to be 13. And when you found your two angles, this angle, KLN, should have been 125 degrees. And this other angle, NLM, should have been 55 degrees. So hopefully you got those two answers. In number 4, instead of adding up to 90, the two angles together add up, instead of adding up to 180, they are going to add up to 90. So you're going to add these two angles together, right? And then EFG, EFH, right? That's what we're going to find. So 3x plus 3 equals 90. So then if you did the math, so 87, so I got x to be 29. They didn't ask me for both angles. They only asked me, oh no, they did ask me for both angles. So EFH is this one. So this one should have come out to be 60 degrees. And then this angle is 30 degrees. And I know that I did a great job because when I add the 60 and the 30, I get 90. So I know that I did, like, everything works out. And then also for number 3, I forgot to mention that I felt pretty good about my answer because the 125 and the 55 together do give me 180. Okay, so I don't have patty paper here, but the idea of being congruent is that, again, you're going to draw an angle that overlaps perfectly. So patty paper is just like sheer, think of like tissue paper or wax paper that you're going to draw over, and just the two rays have to coincide. So the two rays and then the vertex has to coincide, right? So D, E, F. So in if we were in class, you totally would draw this and you would kind of get that. What I'm going to do is I'm just going to be able to take my angle, right? And this is what you would have. And this is basically going to be angle that is congruent, meaning it coincides perfectly on top of each other, but I can move it over. I can even rotate. It's still going to be congruent. It doesn't really matter. Because remember, when you're figuring out if things are congruent, you're allowed to move them around. I'm actually going to even do this for us. Now, to show on a diagram that things are congruent, right? Remember that with segments, if we had two segments, to show that they were congruent, we use these little notches. So we have something similar for angles, but remember when we go from one ray to the X, we sort of travel, we kind of rotate, I want to say, right? So what we're going to do when we mark our angles, we use these little notches, but they're going to go like this. So this would indicate to somebody that angle ABC is, oh my gosh, we don't, no measurement here because it's not, we're talking about the whole physical angle. So angle ABC is congruent to angle DEF. Okay, now let's just think about it for a second. So in order for two segments to be congruent, we knew that they had to be the same length. In order for two angles to be congruent, they would have to have the same degree measure, right? So if one angle was 40 degrees, the other one has to be 40 degrees in order for the two angles to be perfectly aligned. So they have the same degree measure. All right. And we just talked about the notation. So again, the little notches are going to be on the diagram show you that they're congruent. To say that angle measures are equal, notice we're using equal sign. We're talking about measures, so we're here talking about a number, right? We're saying 40 degrees is the same as 40 degrees, right? But here, when we're talking about congruent, we're talking about the actual geometric figure of an angle. So we have to, there's no m's, right? So I'm going to say no m's. So remember, m stands for angle measure. And here we have m. All right. Last thing we need to look at is what it means to be an angle bisector. Well, if I draw an angle, right, and I say to you, draw me an angle bisector. So remember the word bisector means that it has to break it up into two equal parts. So what I'm going to do is I'm going to figure out how many degrees it took me to go from one side to the other. So 1, 2, 3, 4, 5, 6, 7, 8. So 8 wedges means 80 degrees, right? So an angle bisector is essentially going to be a ray that breaks my angle up equally into two parts. So this would be 40 degrees, or 4 wedges, and then this would also be 40 degrees, or 4 wedges. Right? And then to show that they are congruent, so let's say that I didn't have so on a grid, on my little circular grid, I can clearly see that it's 40 and 40. I don't have to really show any marks. But let's say that I didn't have the grid or protractor, but I still want to show someone that these are congruent, or that I want to show that my green ray is an angle bisector. So how would I show that on a diagram without having a protractor? Right, so an angle bisector is a ray that divides an angle into two angles that are congruent. So how do we show they're congruent? Well, I'm just going to do a little notch and then a little notch. Notice that I kind of staggered them a little bit just because then it's clear that the two separate angles are congruent to each other. All right, last example. We are going to draw a picture because notice there is no picture. So they said ray WY bisects angle XYZ. So let's start with angle XYZ, where Y has to be my vertex, right? So I have one ray, and then I have my other ray, and the ray YW has to bisect. So I'm going to do my best, right? I'm going to show that it's being bisected, and then I'm going to label everything. So they said a measure of angle XYW is 18 degrees. And I have to find the measure of x, y, z, so the whole thing. Well, if the two angles, right, so if the angle is being bisected, both of the little angles are 18 degrees. And then all I have to do is just add 18 degrees and 18 degrees, and I'm all done. So 18 degrees, 18 degrees, and then my final answer is 36 degrees. All right, again, I'm going to pause the video and I'm going to ask you to throw in an angle, and after you get a chance to show me your answer, I'm going to play the video and you're going to get a chance to see. All right, so ray BD bisected. So I'm going to mark the two angles congruent. I don't know the total of the angles, so I can't say like little angle plus little angle, but I know that it's bisected, so I know that the 2x plus 20 angle has to be the same measure as the 4x angle. So I'm going to set them equal to each other. And then 2x comes out to be 20, and x is 10. So they asked me about measure of angle ABC. So that's the whole angle, right? So I'm going to throw in the 10 back into my angle. So this is going to come out to be 2 times 10 plus 20. So 20 plus 20 is 40 degrees. And this guy is 4 times 10, so 40 degrees, right? So the measure of the entire angle ABC is going to be the 40 plus the 40. So it's 80 degrees. And that is it for angles.